In this section, we will discuss about zero trust architecture for retrieval augmented generation. So these are the 5 pillars for zero trust architecture, starting from strong identity everywhere, least privilege, continuous verification, assume breach, and never trust, always verify. We will discuss in detail like how it can be done and what are these each step refers to. Okay. So let us start with strong identity everywhere. So this is the first step. Like every user or every service needs to be verified identity. Okay. So for each user, there should be a multi-factor authentication, and also each service. For example, one particular service is requesting another service, then there should be an verified identity between those two. So only verified service. For example, a lambda function was accessing a database, then this lambda function should have identity verified before accessing the database. So these are the steps that should be performed before implementing any retrieval augmented generation system. Like each and every system or each and every user plus each and every infrastructure system should be identified, and it has to be it should have a verified identity, so that while interaction only those which was allowed to access the system. So that's one thing. So here what it actually means is that multi-factor authentication for end users plus the system every service, and also mutual TLS for service to service communication. This is TLS stands for transport layer security, and also short-lived tokens, and there are no static API keys. So this is one main thing we need to consider. Like whenever there is an interaction takes place, then the token should be issued at that moment, and then once that session is complete, the token is revoked. So that way you are maintaining a strong identity, as well as the connections established are done based upon a pure handshake and after identity verification only. And make sure that you are not having any static API keys while designing the system. So that's first step. And then this is something like if you translate as a business, like if you are going to requiring a badge to enter each and every building, and a pin for an elevator, or biometrics for sensitive rooms. So this is multi-factor authentication. Now this is a metaphor for that one. Next we discuss about least privilege. So here no one gets access to everything. So every document request is evaluated individually. Okay, so it means that there are no super user accounts. So no super user accounts means there is no super user where they can access everything. Okay, so no such kind of thing. So for each document there was a role attached. So only those role can able to access those documents. Okay, so this is what we call as attribute based decisions, or user role plus document. Okay. It contain based upon the sensitivity of the document and based upon the context. So which department or which particular tenant they can access. So only those people can able to access those particular documents. So that's how we will design. It's about attribute based decisions. And it's also per document authorization. Like for each document, there's a special authorization. Only those authorized people can able to access. There are different things. One is authentication and authorization. Okay, so here the authorization refers to that even though you are authenticated, or the user is authenticated, or the service is authenticated, but still it should have authorization to access those documents. Only those entities are allowed to access those documents. So that's how we make it as a least privilege, like how and who can access those documents. Next we discuss about continuous verification. So this is like a check on every retrieval. Okay, so we already know, like for retrieval augmented generation, the first step is ingest the documents, convert into vectors, and store those embeddings in a vector database. So that's the initial step. Apart from that, whenever the user requests an answer or interacting with an LM with a chat system, like then when you get the response, even those response or the retrieval, like for that response, there should be retrieval from the database, vector database. So even those retrievals has to be checked for verification. Okay, so this is the step where we do continuous verification on every check, on every check, continuous verification check on every retrieval, real-time policy evaluations, and not just on the login. Okay, so we don't just check permissions every once in the login. So we check every retrieval. It's like a bank checking your balance on every transaction, not just when you're opening account, so that each transaction is validated, whether it is good enough to pass through those checks. Okay, so same way we do the same step, like not only in the login, for each and every retrieval, like when a user assumes an identity, and even though they are authorized for certain documents and not authorized for the other documents, it should not give the unauthorized access to the document when it retrieves or when giving the response. Okay, so such kind of checks has to be performed every time. Okay, so and also the permissions can change. An employee might be removed from the project. The real-time checks ensure that they cannot access those documents anymore. Okay, so for example, in a business there is a team, and in that team there is a person who was already associated with it, and after some time that person was removed and revoked access to certain level. But if you don't have the real-time policy evaluation, then there is a chance that even though that person was removed from the team, he might able to access the sensitive document, which should not be visible to that particular identity. Okay, so this is how we prevent by using real-time check or real-time policy evaluation. So next we discuss about assume breach. Okay, so here we design that we design the rack system in such a way that we already have the attackers inside. Okay, that's what we call it as assume breach. So we do have a segmented networks. Okay, so segmented networks in the sense for each and every team or a tenant, we will have a segmented network, and then only those people or those identities which are allowed to access via those network are able to pass through those network firewalls and then access the system. Okay, so that's one layer of security in the network level, and then we can also have per tenant encryption keys. Okay, so if you have different tenants, and then each tenant have their own encryption keys, so there is no cross link of these tenants. Okay, so if you have those kind of setup, what happens, like by chance or by mistake, if a tenant A, which you should not access tenant C, somehow they are able to access, still they can't able to retrieve the document, or they can't able to perform the required step, because each tenant they have their own encryption keys. Okay, so that's how we avoid those cross tenant data leakage. And also this will help you, like if for example for some reason there is a breach done or has been exploited in one particular tenant, it won't expose all other tenant data as well. So we can confine the breach there itself, and then try to mitigate or try to isolate. So that way we can able to isolate the tenants based upon the encryption keys. And then tamper evident logs, so that's one thing. So the logs are the main thing where data can be exposed or leaked. So make sure that all the data, the logs data you are transporting or make or for further analysis stays within your tenant or within your confined VPC, so that it won't be exposed outside network or outside to the net. Okay, so this is about how you can design your rack system, assuming that if there is a breach or there is a attacker inside, such that how you can mitigate. Okay, so having a segmented networks, and then encrypted keys for per tenant, and also having a tamper evident logs. The next step is that never trust and always verify. So this should be like, so you should not trust based upon the implicit location from where the data has been accessed, and you should always validate each and every request and also audit all decisions. Okay, so here no implicit trust based upon the network location. For example, if you have a different VPCs or VPN, even though the identity or the user connect through that particular VPN or inside the VPC, it doesn't mean it is legitimate. Okay, so that's why we should not implicitly trust, like if there is a request originated from that particular location, okay, immediately open everything and give the response. No, so you should not implicitly trust based upon the location. Even though the request comes from that particular network location or VPC, it should always go through the step-by-step process. You should have the identity verified and then create the session tokens, and then the token should be short-lived, and then make that that particular entity is authorized to view those documents or view those or access those particular system. Then only it is allowed to do that, even though it was originated from that particular location. So that's what it refers to, that no implicit trust by location. And also validate each and every request. Okay, now for example, this particular user created a session and then doing or communicating with the system, and the session was ended. After 2 or 3 hours, again this user request has been raised. That time still again it has to be validated each and every step, and then only it was allowed to access those particular system to get the service. Okay, so and also make sure that you audit all decisions, like starting from giving the access to finally getting the final answer from that particular LLM. So the decisions should be audited, and then it should be it should have a trail. So whenever there is an auditing going on, like you should know like why this particular user has an access and how he can able to get those particular sensitive documents. So that needs to be there. So this is how we can have a zero trust system for retrieval augmented generation. Okay, starting from the first one is strong identity verifier, implementing end user multi-factor authentication, service to service transport layer security, and then short-lived tokens and no static API keys, and the concept of least privilege. So no super users access, like nobody can have access to the entire document or database or the entire system. And also attribute based decisions, like here we already discussed, like user role, document sensitivity, and the context. Based upon that only you need to give the decisions, who and how can access, and per document authorization. So this is about least privilege. And also we discussed about continuous verification, like even though there is that particular user can able to already logged in, it has to be checked on each and every time, and real-time policy evaluation has to be there. And then for each and every retrieval also, that particular verification has to be done, whether this particular user is authenticated, authorized to view these results. Okay, that's one thing. And also no, just not just a login, you need to do a continuous evaluation or real-time policy evaluation of about that particular identity when they're accessing the system. And then finally we discussed about the breach, like while designing the system you should assume such a way that it is already there is a attacker sitting inside. So how you will design? So we discussed about the segmented networks, and then each tenant should have their own encryption keys such that we can isolate if there is a breach in a particular tenant, and also tamper evident logs. And finally we discussed about never trust, always verify, like there is no implicit trust by the location. For example, if the request is authorized originated from a particular network location, it doesn't mean that it is a genuine request. So though it is originated from a specific location, it should be again validated, and then on each stage it has to be validated, and then only it should be passed and audit all the decisions. So this is a 5-step framework how we can design a zero trust retrieval augmented generation system.